Thank you. Good morning. I'm actually very excited that we're hosting the RISC-V Summit here, and what I'm about to go through. We've actually been planning a very special day for all of you today, and I hope to make a substantial announcement and that you'll all be very excited about. And so for all of you, this will be new news, but as I was at home and my wife's been prepping, and she knows that I've been prepping for this particular event, and so she knows today I'm going to be on stage and I'm going to be making this announcement. And by the way, I'm trying to build the suspense here. If you haven't done that. And I make this big announcement, and she goes, "You're going on stage dressed like that?" And I said, "I'll be the best one dressed in the room." So anyways, we are very, very excited to be here, and what I want to kind of start, though, before I get to this suspense building thing I just did, is to talk to you about data and the role of data. Most of you think of Western Digital as a storage company, and I think that we will start to lay the track for you to start thinking of Western Digital as a data company. And so what I want to do is start by talking about data and what it means to us. Oh, I have to start with the legalese. You know, one of the things I want to do with this thing is I kind of want to throw a typo in there and give a prize to who can find it. It makes it a lot more entertaining. So this says, anything I'm about to say is not guaranteed, and so therefore we're all free and clear. All right, good. So, so I said we're going to start with data. So let's take a kind of bit of a historical view through data and where we see data is going. And I think this will just be laying track, and I think all of you will agree with what I'm going through here. So way back when, data was largely just a record, right? It was a bank record. It was just a storage of data, storage of information, but that's really what it was. It was just data as a record. And then we saw an opportunity when networking came around for data to start being about more than just a record, but also about communications and being able to interact with one another, and obviously the advent of the internet and so on and so forth. So it's been pretty exciting. More recently now, data has been really enhancing our lives and making us far more efficient, right? I mean, when was the last time anybody here took out a paper map, right? And I mean, when I travel internationally, for me now, it's like I don't necessarily care about getting lost. You know, I take out my phone and stuff, and 20, 30 years ago, it was a big deal to travel internationally and planning your routes and things like that. So we're far, far more efficient in everything from planning travel to banking to shopping to everything else. So we're just a lot more efficient. But now where we see this going is data is the new currency and the currency of the future. Data is money. And we see a variety of different ways, whether we pay and mobile payments, and whether people use our data in order to change how we, in the example here, how we pay for insurance by tracking how we do. And so we need to think about not just storing data, but doing stuff with data in order to take advantage of this world we're heading into where data is currency. Now here's another framework that we use to think about the data. For the past, I don't know, let's call it 10, 15 years, the talk has all been about big data. And in fact, I'm on the board of Hortonworks, a Hadoop provider. It's all about big data. But increasingly, there are more and more applications, and we'll talk about that, where you live out on the edge, or some of the new applications where you need more immediate access to information. And so we started to think about, well, what does that mean, and how does that fit into the context of big data? We said we think there's also this parallel track we call fast data. And so fast data has a different set of characteristics because it's always with us. It gives us results in real time. We stream the data and those things. So both are active, but we've come now from a world where we've accumulated vast amounts of data, and that's the big data, and now we're increasingly into this world where we want to create more and more applications where the immediacy of data is critically important. And I kind of love this framework because before this framework came out, I kind of had this mental model that I call the time value of data, and it was like really complicated. And so this framework actually really helped me to sort of really simplify this notion by talking about big data and fast data. So the other part of the world that we've lived in is that managing and dealing with the data so far and the big data has been the world of general purpose compute. And all of the data centers today, whether in mobile phones, et cetera, everything is focused around this general purpose compute spectrum. But as we start thinking about the new applications in big data like machine learning and AI, et cetera, and in the fast data world, we kind of say we need to have more special purpose kinds of activities. We need to kind of expand this view of general purpose to be able to attack the specifics of the problem. And it's not just the compute part, but the entire solution stack built around that. And so we see that the needs are expanding far beyond what we have today with general purpose compute. And so to think about general purpose compute, you have to think about it's sort of like a lowest common denominator, right? And so in the example here, if you think about this general purpose architecture, first of all, one thing, everything is centered around the CPU. It's not centered around the data, it's centered around the CPU. The CPU decides how much memory you can have, how much I/O you can have, and all of those things. And then assuming you've sort of reached the best possible lowest common denominator, you have something that's hopefully pretty good. But the odds that it's implemented in the optimal way for your application, for your new machine learning thing, your new genomics environment, the odds are pretty slim. Now, that doesn't mean general purpose compute is bad. It has a lot of applications. So let's use an analogy like a car. It kind of looks like an Audi, and I still have an Audi, and I love it, and it's a great thing, and so it's a general purpose kind of activity. But the thing is that this lowest common denominator, or this idea that one thing solves all problems, needs to be rethought. And that's now where you start thinking beyond this notion of the general purpose view and say, now I need to start thinking about purpose-built. For this application, what is the ideal way for me to process the data that I have? And so this is a great little analogy of my Audi, assuming that's an Audi in the middle, that is the general purpose. But there's all of these other applications, both, as we talked about, big data and fast data, that have a completely different set of requirements. So this is where we now get to, we think that all of these new workloads that are coming at us, that are opening up all of these opportunities, especially for data as a currency, where we see this new set of requirements from a processing perspective, where we want to be more purpose-built, both on the big data and storage-centric world, and in fast data or memory-centric architectures. I spent the last 5-ish years of my time at HPE building something you might have heard of called a machine that was all about memory-centric computing. And this concept of memory-centric computing is becoming increasingly more pervasive, because when you have vast amounts of main memory, you can solve problems that you couldn't otherwise solve when you have to go through a deep, deep, deep I/O stack. So what kind of data-centric environments are we thinking about? So in the big data world, where you store all of this data and then you can do what you can sometimes think of as batch types of activities, analytics and machine learning are really great examples of doing that. And so, and these are the applications that we're seeing in the future that all of you and the industry overall want to take advantage of, where you have this massive storage requirements into the petabyte range, but your processing requirements might be a little bit different. They might be more fine-tuned to the particular data you have. And this new realm of fast data, where you need this immediate access to data, you have another set of applications that are becoming more and more pervasive. So security, event correlation, and blockchain are some of the examples that we have here, where now things like large memory play a role, and specialty processing plays a role. Maybe you want a GPU as your ideal processor. And so this specialized idea becomes more and more pervasive for these new applications. And so this fundamental concept of the CPU as the center of the universe and dictates how much memory and how much I/O and what kinds of I/O and so on you can do starts becoming in the way. It starts preventing us from being able to do everything that we want to do. And so that's a big part of what we think RISC-V brings to the table, is that this open architecture, and as the intro said, I've spent a significant amount of my career working in Linux and open source, so I understand the power of the community and the power that all of you coming together, even if you're competitors, to work towards that common goal, how it engenders incredible amounts of innovation. And that more and more and more innovation opens up new capabilities, and it becomes sort of this flywheel effect that comes together. And when you have this sort of this singular proprietary control over what does this general purpose thing look like and what's its maximum capabilities that don't fit your needs, it kind of prevents you from having this nice flywheel effect on innovation. Now, make no mistake, we are still at the very, very early stages. In fact, I was telling people internally, it sort of reminds me of when Linus started Linux in 1992, and we're kind of like about 7, 8 years later, and the state of things we're at. And so one of the messages I want to leave with you is that you're going to have a number of people out there who say, RISC-V isn't mature, it's not ready, I can't buy it from 22,000 suppliers and this and that, and all this kind of stuff. It's all good. Because nobody would laugh at the power of and the impact that Linux and other open source programs and projects have had in our industry. So that will happen and that will grow, and we have a tremendous amount of confidence in the ability for all of you and the industry overall to basically drive this message of openness and drive this through. And so we have spent a significant amount of time in all of the data center style of applications, and a lot of where we see the new sets of applications are this notion of the stuff happens at the edge. You know, the funny little example we can use is if you have a self-driving car, having that self-driving car say, hey, I'm approaching an intersection, let me send my data up to the cloud and let's hope I get the answer back before I cross the intersection. Right? It's just, you know, that kind of stuff, it doesn't work. Right? So there's these applications where being able to do processing of data and getting intelligence from data as it happens right on the edge in real time are critically important. And that is actually all of the new creative applications where all the work is being done. So we spent the last 10 or 15 years with everything goes to this one big place in the cloud and pick your cloud providers, and that will continue, right? This is not a that stops and now we go do this, right? This is a, hey, we've gone through that phase and that's going to continue, but that has now, we are at a place where we're starting to enable a lot of new classes of applications, and a lot of these are, you know, governed by this term called edge or IoT, and this is where we see a tremendous opportunity, and that we wanted to be able to participate and make a contribution and deliver as part of that opportunity. And this is where we see RISC-V being able to play an incredibly powerful role. Because we think that RISC-V has the capabilities, the foundation, the opportunity, and this concept of openness and the community overall to deliver across both spectrums of big data and the new applications we see there, as you saw, like machine learning and analytics, and also for the world of fast data and all of these edge-based and real-time applications. And so we think that RISC-V is ideally suited to be able to cross that spectrum and be able to deliver capabilities across all of those the spectrums. And the nice thing about it is rather than be CPU-centric, we can now be data-centric. And we start with, what does my data need? What do I need in order to get the most of that data? I need multiple petabytes of main memory? Great, let me go turn that on. Maybe I need a wimpy core and lots of memory. Cool, let's go do that. And there's nobody standing in the way of allowing that to happen. Maybe you need 1,000 or 10,000 cores and very little I/O. Great, let's go optimize for that. And so we'll see classes of applications where we can go do that. And because RISC gives us, RISC-V gives us everything from 16 to 128 bits of scalability, from embedded to the enterprise. And sure, is there work to do? Absolutely. But now we can do that work with a clean sheet of paper, and we can solve this new class of problems that are coming to us. So if we go back to this picture of the stack and being able to deliver across the big data to fast data spectrum and being able to solve memory-centric architectures or storage-centric architectures and deliver value from the data, RISC-V has the capability to take us there. And is it, again, is it all ready today? No, and all of you will deal with some of this, right? And I'm trying to leverage and share with you some of the early stuff that I felt with in the very, very early days of Linux. And just a little story there. I was actually at one point running both Unix or HPUX and Linux. And the internal battles of all of the HPUX people who said, Linux will never measure up. It'll never be as good. It'll never be as mission critical. I mean, I have heard it all. And you're going to get the exact same thing here. Just be ready for it. Respect it. But know that as a community, the power that we bring is to basically bring that up, and we will be able to solve problems. And and here's the other critical part. Don't go just duplicate what the world has done today. So if all you did, for example, is say, I'm going to take a RISC-V processor and I'm going to make it look like an x86 or an ARM, or pick your processor, you're missing the point. The point here is about the data. Start from the data. That's where the power is. And say, what do I need in order to solve the problems that I have for my data? Make the processor a means to an end, not the end unto itself. And that will cause your brain to start shifting how you approach the problem. And that's where the real opportunity is for us in storage and in memory. So we think that RISC-V has this ability to meet the needs of both big data and fast data. And our work internally and our contribution to the RISC-V world will be to span this spectrum of understanding all of the various data types so that we can optimize and deliver solutions that are optimized for those specific applications. So how are we going to do that? Well, so here's a little tidbit of data that a lot of you may not be aware of. Western Digital today ships in excess of 1 billion cores a year. Now remember the suspense I was building? Are you ready? Western Digital is making a commitment to transition those 1 billion cores a year all to RISC-V across our entire product portfolio. So I'm excited. So, and this is what is so powerful for us, is that from a Western Digital perspective, this opens up a wealth of opportunities where we build storage and memory products, where we can now bring the power of RISC-V, our ability to extend the architecture, the ability to bring new instructions to the mix, the ability to put the processor right next to where the data is and process the data where it is rather than shuttle data around the data center. And that's actually a key point I want to emphasize. Today, when we think about storage and data, we do think about let's go grab all of this data from somewhere in the data center, let's bring it all and move it to a central location, let's do a bunch of stuff to it, and let's get some interesting answers, then we shift a bunch of stuff back. And a key part of our objective, just so you understand, is how do we move all of that work right to where the data is? Let's stop all of this unnecessary movement of data, and let's go process the data where it lives. And that's a big part of what the big data RISC-V combination will allow us to do. And so you'll increasingly start seeing us introduce devices where the general consumer might not actually be aware that there's a RISC-V processor in there, just like today. When you buy an SSD or a USB device or anything, you don't know what's inside. But for us to be able to create new instructions, to enhance as part of the community, to leverage the investments from the community overall, is fantastic. And that's another key point of all of this, and as part of the internal conversations we had, is like, oh my God, like if we start doing this processor stuff, there's a lot of work to go do there. And I said, look, I've seen this being done in the Linux and open source world. We don't have to do it all ourselves. We have to be key contributors. We have to be key members. We have to contribute everything from hosting the RISC-V Summit and giving you all a really cool lunch. I hope it's good. And making it entertaining. And so we'll make those contributions. We will make the technical contributions. In some cases, we'll develop our own cores. And in other cases, we will buy cores and we'll leverage somebody else's work. In other cases, we might join with another company and co-develop cores. Right? It's kind of a new style of development that is new for Western Digital. But it's actually really, really powerful and a lot of fun. Some of the most fun I tell people that I've had in my career was when I was deep into the Linux and open source environment. I was the HP guy, and some of my best buddies were from IBM. And at the time, we were fierce competitors. And if my buddies in IBM and I were in front of a customer, we would have been, duking it out like hard competitors. But when we were in a room working together for the betterment of Linux and the open source community, we were best of friends. And it was really a fantastic model, and it worked very, very well. And so this RISC-V movement that's been around now for a number of years is at that stage where I think the same thing can happen, and I think all of you can help create that. So part of the mission all of you have is to not make me look bad for transitioning all of these billion cores to RISC-V. So, all right, so I've still got lots of time, but I'm going to finish a little bit early. I hope you don't mind. I'm trying to protect my voice here. So, but anyways, here's some of the stuff we want to go do, right? So we want to support the development of open source IP blocks, okay? And a lot of the work we're going to do is going to be all in this open source spirit where we contribute all of the logic work that we do into the open source world for the betterment of RISC-V overall. We will actively partner and invest in that RISC-V ecosystem. And as part of that, the other announcement we have for today is following me, Dave Ditzel from Esperanto will be coming on stage, and Western Digital has made an investment, and I don't want to steal his thunder, but he's going to tell you about some of the exciting RISC-V development at the high end of the core development. And so we were very, very excited to work with his team and make an investment to ensure the success of his company as he grows the RISC-V at the high end of the capability spectrum. And so I hope you'll stick around and listen to Dave go through that, because I think it'll be a very exciting talk. I actually was able to see it ahead of time, so it's pretty cool stuff in there, and I hope you'll listen to that. But that's another example of where we will be making those investments in order to help the overall world. And then our focus is going to be on purpose-built processors. So here's one of the confusions and nuances, what I'll describe as a nuance in the system. So RISC-V can be a general purpose processor. And I just finished telling you, well, you know, we don't care about the general purpose world. We're all about special purpose, all that kind of stuff. And so those things are not inconsistent, all right? It's just, it's a nuance, and we'll kind of work through it. So the thing is that we're not doing this because we want to be another general purpose processor. We're doing this because we have the ability to extend a general purpose instruction set to special purpose activities focused on big data, fast data, storage, and memory. And so we essentially get the best of both worlds by having a processor that can participate in the general purpose world and run Linux operating systems and all that good stuff, and that gives us a bigger community. But our focus from a Western Digital perspective is on our ability to deliver special purpose capabilities that add value to the data that the world entrusts on our devices. And so the other part of this is not a one and done. So what I'm not doing here is I'm not announcing a RISC-V product. I'm not announcing a RISC-V processor or a RISC-V core. In fact, the most likely time frame where our first device out there will be based on RISC-V is probably late 2019 to 2020 kind of time frame. Somebody in the room just panicked by me saying that, by the way. The reason why we're talking about this now is because of all of you. It's the ecosystem. The reality is, whether you're a company, you're an individual, you're an investor, you're a developer, you want to know that the work you're going to do is going to be part of a great big whole, that you're not going to be alone in this small little thing. And so our goal today was to say, if Western Digital is committing to transition 1 billion cores to RISC-V over the next few years, we are basically telling the industry that RISC-V is in, it's ready, get on board, and your investment is sound. And whether that's a monetary investment, a resource investment, or any other kind of investment, it's all really good. And so, so we hope that our announcement will be a Kickstarter or an ignition switch to really get the ecosystem to get broad. And so for me, a big signal for this will be, you know, the next RISC-V Summit or the one after that needs to be at the Santa Clara Convention Center because it can't possibly hold everybody who wants to come, right? That's the kind of thing we want to get to, and we want this to be big. And because we want to be able to leverage what all the stuff is going in there. And here's another little tidbit. This is kind of a little bit of a personality profile for me. I actually count on and I depend on what I call the serendipity effect. So what happens is there's a set of people out there who like to see, you know, very well defined R&D plans and roadmaps and what is this going to look like, and tell me by month, by quarter, by year exactly what you're going to do and what it's going to look like, etc. And I don't know, I'm just wired differently. When I see RISC-V, I see an incredibly powerful foundation. And from that foundation, the possibilities of innovation are absolutely incredible to me. But the thing is, I cannot predict, no matter how much of a crystal ball soothsayer you think you are, I cannot possibly predict what all of those innovations are going to be. And so my message to you is, like, go do cool stuff and come show me, because I just can't wait to see it. But that is a serendipity effect, and I'm counting on it. I am absolutely counting on it, because I know I've lived in this world for too long. See the gray hair? I'm old. I have seen this effect in play. And I've already seen it inside Western Digital. In fact, I'll even tell you the story because I have some time and my voice is holding up, so I'll tell you the story. So one of the things that I did internally as we were going through this was, should we do RISC-V with our hard disks, right? So hard disk company, do a hard disk controller. So I head over to, I had given a heads up to the management team over there. And so they had prepped their engineering team. Hey, Martin's coming over. He wants to talk about RISC-V. What could we do with our hard disks, right? And so I was like very much predisposed, and so my brain had been pre-programmed to what could we do with RISC-V if it was on the hard drive, or we would process the data on the hard drive, right? And we would do some interesting things on the hard drive. And so that's what I was going to Rochester, Minnesota, tourist capital of the world. And said, let's go see what this team's got. So I get there, and the team's very excited about this, and they went in a direction that was like completely different than what I expected. Because they said, look, with all of the new hard drive innovations, you might have recently heard of our MAMR, or technology that we've recently announced, where we do the microwave-assisted recording. A few years ago, we talked about SMR, the shingled magnetic recording and stuff. Well, what happens is those technologies require a lot of pre-staging of data and information, and there's a lot of metadata about the drive, keep it simple. And so where their brains went was, hey, if I had a RISC-V processor on the hard drive, I can actually manage a fleet of hard drives so much better, so much more efficiently, and I can manage all of the data placement and the complexities of MAMR and SMR using that processing capabilities, and I can take some of our, specialized capabilities and understanding of the device and embed that right into the instruction set for RISC-V and do it at very low power, high efficiency, okay? Totally, completely unexpected. Right? But I'm just giving you an example of this serendipity effect that I count on, because I know that all of you will come up with your fantastic idea in ways that I can't possibly imagine. And so this has, this is the kind of stuff that's already started happening inside of Western Digital, and it's always like very, very exciting to see. All right. So this is, hopefully, this is an exciting announcement. I dressed up for it. So it's about big and fast data, and it's about purpose built, right? So we are not doing this because we want to be in the processor business and start generating general purpose processors for the world. We're not doing that. We have no expectations of ever directly selling a processor, okay? That's not why we're doing this. The second key point here that I want to emphasize that I missed in this is we're not doing this for cost reasons. So that's one of the questions that I've gotten as we were briefing people is, oh, are you trying to save development costs? Is that like you're going to rip cost out by doing that? You're a big company, you got to take cost out? I said, no, it had nothing to do with it. In fact, if the only motivation was cost, we wouldn't be doing this at all. This is all completely, totally about innovation. And it's about unlocking our ability to, without negotiating and working with the community, being able to bring innovation to data and process data in ways that we can't contemplate today. I've got a lot of experience with the openness of this ecosystem. And in fact, I think this afternoon I have a phone call with one of our key competitors. It's already starting, and I love it, right? A phone call I probably wouldn't have taken 6 months ago. I am like excited to take and talk about to accelerate RISC-V. And so that's really what this is about. And our other contribution today, and I hope you'll agree with me that this is a substantive contribution, is our commitment to transition our entire product portfolio with 1 billion cores over to RISC-V and bringing that momentum to the overall ecosystem. That's it. Thank you very much. And I hope you have a great rest of the summit.